Today we're going to talk about inverse variation. You guys have done direct variation in Algebra 1, which direct variation is just when you set up a proportion and cross multiply and solve. Inverse variation is going to be a little different. Inverse variation, one of the best examples that I think helps people understand inverse variation is to think about workers doing a certain job. So maybe they're building a house or painting or doing some sort of job. So let's say we only have one worker and it takes him 20 days to do this job. But what if we double the amount of workers we have and now all of a sudden we have 2 workers? Well, more workers means it'll take them less time. If we double the workers to 2, that makes the job take half as long, so the job would only take 10 days instead of 20. Same thing if we doubled the workers to 4, now it would only take us 5 days. And we can keep kind of doing that, but in general you should see that for each one of these, the products are all the same, and the product in this case would always equal 20. So that's why we are multiplying within this inverse variation. Whatever you have the product of for the workers times the days here has to be the same product for workers times days. So that shouldn't say job, that should say days here. Okay. So that should hopefully make a little bit of sense. Let's use that to do this first problem where we talk about people on a seesaw. So kind of physics tells us that if you are heavier, you can be closer in towards the balancing point of a seesaw. If you're lighter, you have to be a little further out to make yourself have as much effect as the heavier person closer to the fulcrum. So here it says, how far from the fulcrum must a man who weighs 160 pounds sit if his 50-pound son is sitting 16 feet away? So this is the pounds, this is the feet, this is the pounds. Here we're going to look for the feet. We'll call that x. Okay? So pounds times feet equals pounds times feet. So we get 160x equals 50 times 16 is 800, and if we divide both sides by 160, we're going to get 5. So the answer is 5 feet, which again should make sense. His son was like a third of his weight, so he's 16 feet away. The father can sit a lot closer, 5 feet away. Let's try the next one. Now the boy's got a cousin. He's 80 pounds. We want to figure out how far away he has to sit. And again, we know the boy is 50 pounds and he's 16 feet away. So if we do this, we've got 80x is equal to 800 again. Divide by 80. And you get x is 10. So this cousin would have to sit 10 feet away. He's not as heavy as the father was, so we can go a little further out, but he's still heavier than his cousin is, so he is going to not be as far as the 50-pound kid. Okay, these are pretty easy in number 2. We're given x and y, x and question mark. So x times y here is equal to x times y here, if they're inversely related. 18 equals 6y, divide by 6, 3 equals y. Same thing for b. 3 times 12 equals x times 6. 36 equals 6x, divide by 6, x equals 6. Last one, when you solve that, y equals 40. Okay? So, really, really easy when it's just numbers. What about number 3? 2 variables, w and z, again, vary inversely. So that means as one increases, the other has to decrease, and vice versa. Now, we don't really want to talk about increasing by 3, because inverse variation is based on multiplication. If we double something, the other thing gets cut in half, like we talked about with the workers and the days for them to do a certain job. So number 1 and 2, not really what we want to be looking at. 3 and 4, if w is multiplied by 3, then z is divided by 3. That seems good. Let's look at 4. W is multiplied by 3, z is multiplied by 3. This would be direct variation. Inverse variation, choice 3. Let's go on to the next page. Another word problem. The force needed to pry a nail from a piece of wood varies inversely, so that's important. You need to see that it varies inversely. They're going to tell you that within the problem. With the length of the crowbar used to remove the nail. If a 6-inch long crowbar requires 15 pounds of force, so we're talking about the inches times the pounds equals inches times pounds. So a 6-inch long crowbar requires 15 pounds of force. How many pounds of force would be required by an 18-inch crowbar? So now we solve this, we get 90 equals 18x. We divide by 18, we get x equals 5. So our answer would be a 5 pounds of force would be required by the 18-inch crowbar. Let's look at number 5. The amount of time that it takes for Carla to drive home from work each day varies inversely. So again, they're telling you it's inverse variation with the speed at which she's driving. If it takes her 45 minutes to drive home in rush hour traffic when she's moving at only 15 miles per hour, how much time does she save? That's in italics, so it must be important. If she can drive traffic-free at 50 miles per hour. So we're looking at the minutes times the miles per hour. Minutes times miles per hour. So it takes her 45 minutes if she's driving 15 miles per hour. But because it varies inversely, we're going to multiply that. And it'll take her X minutes if she's driving 50 miles per hour. Well, 45 times 15 is 675 equals 50x. And if we divide by 15, we get 13.5. So it would only take her 13 and a half minutes if she drove 50 miles an hour, which should make sense. You're driving faster, so it should take you less time to get wherever you're going. But that's not what the question asked. It didn't say how much time would it take her. It said how much time does she save if she drives 50 miles an hour instead of 15 miles an hour. Well, it was going to take her 45 minutes. Now it's only taking her 13 and a half minutes. So how much time is she saving? 31 and a half minutes are being saved by her going 50 miles per hour instead of 15. Now, hopefully she's still following the law and speed limits for that particular area that she's driving in, but she is going to save herself 31 and a half minutes. Okay, and lastly, inverse variation as far as a graph goes. If you needed to solve x times y equals 8, which that's an inverse variation equation because you're multiplying x times y. If we wanted to get y by itself, we could divide by x and get 8 divided by x. So if we made a table for that, x, y, let's say we did 8 divided by 1. Well, that would be 8. 8 divided by 2, 4. 8 divided by 0 would be undefined, can't do that. 8 divided by, let's do negative 2, would be negative 4. 8 divided by negative 1 would be negative 8. So those are a bunch of points we can plot for our graph for x times y equals 8. 1, 8. 2, 4. 0 is undefined. We're not going to plot that. We also could have put on there when x is 8. Y would be 1. When x is negative 8, y would be negative 1. So 8, 1 would be here. And I guess we could have used the 4s too. Positive 4 would give us positive 2. And negative 4 would give us negative 2. So 1, 2, 3, 4, 2. So here's one part of my curve. We'll talk about the undefined part of this. I'll plot the other part, and I kind of did these in a weird order, but negative 1, negative 8, negative 2, negative 4, negative 4, negative 2, and negative 8, negative 1. There's the other part of our curve. And because our graph is undefined at 0, we have an asymptote there at 0, which we've talked about before. An asymptote just means it's like an imaginary wall that you can't cross. The graph can get really close to that line, but it can never cross it. Now, why is there an error there? Well, there's an error there because when x is 0, our equation says 8 divided by 0, and we know we can't divide by 0 because it makes the equation, the fraction undefined. So that's why we're getting that asymptote there. There's never going to be a part of the graph that exists right here. It just can't happen because we can't divide by 0. Okay? So that's what inverse variation looks like graphically. As far as algebraically, inverse variation is really easy. We're just going to multiply. That's it.